To prove or verify identities, do the following. Work on only one side of the equation. Remember, you want both sides to be identical. You can start with either side. Use algebraic manipulations and/or the basic trigonometric identities until you have the same expressions as on the other side. Suggestions. Start with the more complicated side. Try working to change all the functions in terms of sine and cosine. Try the following algebraic manipulations: simplifying, factoring, adding, subtracting, fractions. Here's our problem. Tangent of x plus secant of x, prove that it equals cosine of x over 1 minus sine of x. Since we have a fraction on the right, let's try working on the right side. We'll multiply by 1 in the form of 1 plus sine of x over 1 plus sine of x, which, when distributed in the denominator, will give us the difference of two perfect squares. So we distribute cosine of x in the numerator and use the FOIL method in the denominator to get cosine of x plus cosine of x sine of x over 1 minus sine of x squared. You can now substitute in the denominator using one of the Pythagorean identities to simplify the denominator. Remember that sine squared x plus cosine squared x equals 1. So by subtracting sine squared x from both sides of that equation, we see that cosine squared x is equal to 1 minus sine squared x. So we can substitute cosine squared x for 1 minus sine squared x in the denominator. Let's bring our work up to the top of this slide since we've run out of room on our screen. Just continue working down your paper. Now we should try splitting up the fraction. That would enable us to cancel out some of the cosines. So you can see from both fractions, anything divided by itself is 1. That enables us to cancel out cosine of x over the cosine squared of x in the first fraction. We get left with 1 over cosine x. And in the second fraction, the cosine x over cosine squared of x leaves us with a cosine x in the denominator. We'll rewrite these fractions using an identity. Remember that the secant of x is equal to 1 divided by cosine of x, and the tangent of x is equal to the sine of x divided by the cosine of x. Once you've made that substitution, you've proved that the left side of the equation equals the right side of the equation.